5.8, rational zero theorem. So this is kind of the end of this lesson, chapter. And this is very similar to the last lesson, which was how to find all the real zeros. And I'll find the real imaginary zeros of a function. The biggest difference between this lesson and last lesson is this. Last lesson, I said first thing you do is graph it. And let's say there's x to the fourth graph, and you graph and you got this. You're like, okay, I have two x-intercepts, they cross nicely, I know what they are, it's -1 and 1, and then since it's x to the fourth, I have two imaginary, so I gotta go through the process to find the two imaginary roots. What's the difference now is this. I'm gonna give you a graph, it might be x to the fourth, who knows. The difference is gonna be in the fact that now, it's not gonna cross all nicely. You're like, that looks like it might be 1, but that, I have no idea where it crosses. That's a rational root. It's real across the x-intercept, but I don't know where it's at. So that's a rational root. It's going to be something like 2/3 or 4/5. Who knows where it crosses? So for that, we need a rational zeros theorem that we're going to use, which limits the possibilities of what that could be. So that's the biggest difference between this lesson and last lesson. It's the same idea. We're going to find all the zeros. So the difference now is it's not going to cross nicely. Life isn't all easy. It's going to cross ugly at times. We've got to find fraction and decimal answers. So let's just kind of get into it. So the rational zero theorem says this. The only possible roots, so these are possible, it helps you find possible rational roots, come from when you put the last term. So let's do this example. Let's give you 3x squared 4 plus 2x cubed plus x minus 5. And when you put the last term, the factors of the last term over the factors of the first term. Now it says PQ here because they start with the P function, they end with the Q function. I guess they start with the Q. Start with the Q function with the P function, but it always confused me. Last over first. So in this case we'll put plus and minus 5 over plus and minus 3. And it's not just those two things, you have to put all the factors. So the factors of 5 are 1 and 5. And the factors of 3 are them in front, last over first, 1 and 3. And I gotta do every single combination here. So I can do 1 over 1, which is 1, 1 over 3, so plus and minus 1/3. Then I gotta do the 5 combinations, so 5 over 1, and 5 over 3, so plus and minus 5, and plus and minus 5/3. So those 8 possibilities, right, there's 4 but plus and minus, are the only possible rational roots. Of all numbers in the world, those are the only ones that might work. I'm not sure which ones we actually got. To figure out which ones work, we gotta go through the process to find a 0. Right, the ones that work are when the remainder equals 0. So we actually go through the process to figure out which one works, but those are the only ones that might work. That's actually kind of big. Of all the numbers in the world, any number could possibly, the infinite amount of numbers, only these 8 might be the answer. So that's why it's a big theorem, an important theorem. So first let's talk about how to write the rational roots. So that's step 1. So all I want to do is find the possible rational roots here. And the way this works, it's the factors of the last over the first. So here's my last, so plus or minus 15 over the first, plus or minus 2. So my factors of 15 are plus or minus 1, plus or minus 3, plus or minus 5, plus and minus 15. Factors of 2 are plus or minus 1 and plus or minus 2. So then now we're going to do all the combinations, so 1 over 1, 1 over 2, 3 over 1, 3 over 2, 5 over 1, 5 over 2, 15 over 1, and 15 over 2. So again, it's a lot. There's 16 things there. There's 8 and then plus and minus. But it's still a lot less than just guessing randomly. So it lets you know, okay, it's going to be one of these. I just got to figure out which one it is. Or maybe 2 of these. So again, very important, very powerful theorem there. So let's break it down from all infinite many numbers to just these, in this case 16. Let's do one more of these, let's get the idea across. So possible rational roots. So possible rational roots, right? So last over first, factor the last over first. So I get negative plus or minus 18 over plus or minus 3. Now, everyone wants to like divide this, like, oh, I could reduce that 18 over 3, 18 over 6 to 3. Doesn't work that way. Sadly, you actually got to write it all out. So all possibilities of 18 are 1, 2, 3, 6, 9, and 18. All the possibilities of 6 are 1, 2, 3, and 6. Right? So again, you cannot reduce. It doesn't work that way because we're talking about the factors of it, and the factors of it are not going to automatically reduce. So we have that, and then you do all the possibilities. So 1 over all of those, so it'll be 1, 1/2, 1/3, 1/6. And then 2 over all of them. Now 2 over 1 is 2. 2 over 2 is 1. I actually already have that, so I don't need to write that one again. 2 over 3 is 2/3. 2 over 6 is 1. 2 over 6 is 1/3, which I already have again, so I don't need to write that. So it does get a little easier. 3 over 1 is 3. 3 over 2 I don't have. 3 over 1 is 1. I have that already. 3 over 6 is 1/2. I already have that. So then you go 6. You go plus or minus 6. 6 over 2 is 3. I have that already. 6 over 3 is 2. I have that already. And 6 over 6 is 1. I have that already. So we can move on to 9. So get plus or minus 9. 9 over 2 I do not have. 9 over 3 is 3. I have that. 9 over 6 is 3/2. I have that. So there you go. Then 18. 18 over 2 is 9. I have that. 18 over 3 is 6. And 18 over 6 is 3. So like it looks like it's going to be a lot worse, but it's not that bad. It's still annoying. Yes, it's still annoying. I know. But it's not that bad. Those are, again, that's still powerful. Those are the only ones that might work. Of all the numbers in the world, I know 25 is not going to work. I know 10 is not going to work, right? It has to be one of these numbers that might work. So let's put this into action. And I'm actually going to skip this first one because that first one's ugly. We might go back to it later, but let's do an easier one to start off. So here, so remember, let's review the steps. If I want to find all the zeros of these functions. So step 1, I was just graphing it. You can do it without graphing it, but it's a lot of guessing. So I'll say graph it. Now again, if it graphs it nicely, then you're done. Those are your answers. But if it doesn't, then you got to do the possible rational roots. And then we're going to do syntactic division on those possible rational roots until we get to x squared. And remember when I say until, or like keep on doing it, remember you want a remainder at 0. That means it's a root. Roots are a remainder of zeros. So you plug the possible rational roots into syntactic division, look for the zeros. Right? And then once you get one, just keep on going down. And then once you get down to x squared, then you can use factor, you can use a quadratic formula. Or root the square if you want. So that's the steps, that's the process. Let's do it. So step 1, let's graph this. I think I already typed it in. Yeah, so I typed it in, hit graph, and you get this picture. So it looks, if you look at it, it looks like it crosses in between 1 and 2. And maybe at 1, maybe, and before 3 it looks like. I'm just doing a quick sketch so I have it, so I can refer to it. 1, 2, 1, 2, 3. So like I said, between 1 and 2. Maybe at 1 I might be off, and maybe at a little before 3. So into that effect. Right, so it doesn't cross nicely. That means I gotta do possible rational roots. So possible rational roots. So remember, we're gonna do the last row first. Plus or minus 5 over plus or minus 3. So the high degree term and the constant term. My factors of 5 are 1 and 5. That's why I want to do this one first. Factors of 3 are 1 and 3. Right, so all the combinations are just going to be 1 over 1, 1 over 3, 5 over 1, and then 5 over 3. So again, of all the numbers in the world, only these 8 might be a solution to this. Only these 8. So how does this work? Well, first let's cross out ones that cannot be it. It can't be 5, right? 5 is over here somewhere, and negative 5 is over there. So this is definitely not it. 1/3? Maybe. I don't think so though, because none of them, like, I would say 1/3 is not it either. So it's going to be plus or minus 1, because that could be -1, or that could be positive. I guess that could be positive. I think it's supposed to be halfway in between. And that could be easily -5/3. That could be easily be 5/3. So, however, even for the ones I had, I was able to cross them out that obviously were not the right answer. And I have a lot easier things to check on now. So, let's do syntactic division. Alright, so I have 3x cubed minus 2x squared minus 8x plus 5. I want a 0 there at the end, right? That's the whole point of this. I want it to be a root. And then we just guess. I'm going to use 1 first. Let's see if 1 works. So you bring the 3 down, multiply across, add, multiply across. -7, multiply across, -7, and I get -2. So 1 did not work. That did not cross that 1. So that I'm glad it happened though. I want to show you that. Great, that's a bad result. I want a 0 there. So let's go back to the drawing board. Erase the work we did, or write a new one. Plug another number in. I know positive 1 doesn't work either. Let's try -5/3. That might be -5/3. So -5/3. Bring the 3 down. Multiply 3's cancel. I get -5. Add -7. That's not gonna work either. I can already tell, right? -7 times -5 is 25/3. I have to divide evenly. It's gonna be a mess. So -5/3, also not good. I'm just not very good at guessing right now. So let's try +5/3. The only thing that's really left based on the ones. Or I crossed some things out I shouldn't have. Let's try +5/3. Let's see if that crosses that +5/3. Bring the 3 down. Multiply across. 3's cancel. I get 5. Add. I get 3. Multiply across. 3's cancel. I get 5. Add. I get -3. Multiply across. 3's cancel. I get -5. And finally, I get a 0. So that's a root, 5/3. Now remember, we still got to find the answer to this. So this is always 1 power less. That's x cubed. So this is 3x squared plus 3x minus 3 equals 0. Remember first rule factoring or solving, factor out monomial. These could all divide by 3. So let's make our life a little easier. And I get x squared plus x minus 1 equals 0. And that is prime. You cannot factor that. So let's do the quadratic formula. We got to find the solution. X equals 1 plus or minus 1 squared minus 4 times 1 times -1 all over 2 times 1. This is 1 minus 1 plus 4, double negatives. So I get x equals 1 plus or minus rad 5 over 2. So those are my 2 solutions, and that's my other solution. All my 3 solutions are that and 5/3. Right here I have 2 irrational solutions. That's why they didn't come up with my rational root theorem, but I do have my rational root answer right there. So that's the process, right? Graph it. If it works nicely, you're good. If not, do the possible rational roots. Once you get it, keep on trying synthetic division until you get a 0. That's what we need, right? Because it's a root to 0. And once you get down, keep on doing that until you get to x squared, and then you can just factor use the quadratic formula. So another one. This is right here. So this one's x to the 4th. So this one, I'm going to do synthetic division at least twice, right? I got to get down to x squared. So it's x to the 4th. I got to do it 2 times. So let's type this into our calculator, which I just did off camera. So it's all typed in. Hit graph. Let me fix my window. I think I changed it, or I was looking at something. So zoom standard. And it crosses, look, it crosses before 1 and between 1 and 2. And there's something else I noticed I'll point out in a second. So my graph kind of looks like this. Again, since it's a sketch, so I have some idea what I'm looking at. I do want to point out, notice there's only 2 x-intercepts. So there's 2 real roots. We have x to the 4th, so there's going to be 4 roots in total, 4 complex roots in general. So there must be 2 imaginary roots. So we're going to have eyes in this problem. So anyway, they don't cross nicely. I gotta list all my possible rational roots, the ones that might work. So last word first, plus or minus 15 over plus or minus 4. Factors of 15 are 1, 3, 5, and 15. Factors of 4 are 1, 2, and 4. All the combinations, 1 over 1, 1 over 2, 1 over 4. 3 over 1, 3 over 2, 3 over 4, 5 over 1, there's a lot of them. 5 over 2 I don't have already. 5 over 4 I don't have either. Oh, there's a lot. And then 15 over 1, 15 over 2 I don't have either. And 15 over 4. Whew. Right, so those are the possible ones. Now again, it looks like a lot, but we cut some stuff down. Does not look like it crosses that 1 or -1, so I'm going to cross out 1. It doesn't cross that 3 for sure. Doesn't cross at 5 or at 15. 3 halves totally could be 3 halves. Like, looks like it might be. Looks like it might be 1 half. I don't think it's 1/4, but my picture's not perfect, so maybe 1/4. Maybe 3/4. I don't think 3/4. But like, so we cut it down a bit. It's actually not going to be 5 halves either. That's 2, and nothing goes more than 2. Could be 5/4. But my best guess is, it can't be 15/2 or 15/4. Those are wrong. Right? So you could cut down based on your picture. Like, it's nothing more than 2. So all the things that are more than 2 are gone. Right? It's nothing even. So anything that's nice, gone. Right? So these are my choices here. I'm going to try probably 3 halves first. Maybe 1 half. See which one works. Anyway, let's do synthetic division. 4x. Let me just rewrite it first. These are big numbers. Alright, so we're going to have 4, negative 12, 25, negative 14, negative 15. Remember, the whole goal is to have a 0 here. We want a 0 there. And it all depends on what we want to try first. I think I said I was going to try 3 halves first, so let's do that. Because that looks like 3 halves to me. Doubling it. We have better luck than I had last time. So bring the first one down. Multiply across, I get 12 divided by 2 is 6. Add negative 6, multiply across. 18 divided by 2 is negative 9. Add down, I get 16. I'm feeling good about this. 8 times 2 is 24. Add down, negative 10. 30 divided by 2 is 15. Is that negative 15 now? This is a positive 10. Oh, almost messed myself up. So, positive 10, positive 15, 0. Woo! So that works. That's one root. Now, here's a very important thing, though, right? This is x to the 4th. This is now x cubed. You always go down 1. So we got to still keep on working. We're not done yet. Remember, I got to get down to x squared. That's the whole goal. Well, getting a 0 and getting down to x squared. So I got to do it again. So I already tried 3 halves. You could go back and like regraph this answer if you want, but basically this is what we have. So 3 halves look like it works. I'm going to say 1. So this one's done. I got this one. It's 3 halves. Found you. That one looks to me like negative 1 half. So I'm going to try that. If not, I have to try like 4/5, 3/4 or something. But 1 half I feel good about also. So again, I'm going to use my answer. I'm not going to go back to x to the 4th. I'm going to use the thing. I'm going to move on from what we have. I'm going to try negative 1 half. I feel good about this one too. So 4, negative 6, 16, and 10. Bring the 4 down. Multiply across, so I get negative 2. Add down, negative 8. Multiply across, I get positive 4. 20 times I get half. Negative 10, another 0. Rolling. So now we found 2 solutions, 3 halves to negative 1 half. This was x cubed, so I have 4x squared minus 8x plus 20 equals 0. We got to solve this again. You can either factor, use quadratic formula. I know it's going to be imaginary, so it's going to be quadratic formula. But again, let's make life easier. Notice they all divide by 4. So I get x squared minus 2x plus 5 equals 0. As you can tell, it's not factorable. So I'm going to do a little quadratic formula. X equals negative b plus or minus b squared minus 4a times c all over 2a. So I get 2 plus or minus, this is 4 minus 20, so negative 16. So 2 plus or minus negative 16 over 2, which is 2 plus or minus 4i over 2. Now remember, the 2's don't cancel. Doesn't work that way, right? You got to factor out, did it divide everything by 2 or factor out a 2? The 2's do not cancel. So now the 2's will cancel because we multiplied. So I get 1 plus or minus 2i. Don't give me 4i as the answer. Give me this. Anyway, that's my other 2 answers, right? My 2 imaginary roots right there. So in all, my 4 roots are 3 halves, negative 1 half, and 1 plus or minus 2i. So that's how I find all roots of a polynomial function, right? It's always the same thing. It's graph it, see if there's any nice ones. If not, do possible rational roots, last word first. You can cancel out the ones you think are not going to work by looking at the graph, and then it's really just kind of a guessing game. Now you can do an educated guess based on the graph. That's what I try to do, but you try to get a 0 until you get, and keep on doing that until you get to x squared. So I did it once here, and I got to x cubed, and I had to go again. Click another one until I got x squared, and then I could either factor use quadratic formula. Okay, one last problem. The volume of a triangular prism is 210 cubic inches. Find the dimensions of the solid. So when we find x here. Now again, volume, if I'm not sure what volume is always the same thing. It's area of the base times height. That's how you find the volume of anything. Area of the base times height. Except if it's pointy. If I could stab somebody, like this one right here, how it's like a pointy pyramid, like pyramids and cones, then it's 1/3 area of the base times height. So that's the form we're going to use here. 1/3 area base times the height. Now, let's look at this problem. So the height's always the thing with the right angle. So that's my height. That is the height. So my height's going to be 5x plus 3. My base here is the right angle too. The area of a triangle is 1/2 base times height. So my height's going to be 1/2 x times 2x minus 1. So that's my area of the base. 1/2 times x times 2x minus 1. And then there's a 1/3 on the outside. And that all equals the volume when they told me the volume was 210. So they want me to solve this. And like, if you remember what I said before, is what they want you to do is multiply this all out, set equal to 0, find all the rational roots, all that stuff. That's like a 30-minute problem. If I have this in this application problem, feel free to use your calculator. I'm just going to go over this again because it's so important. You got to know how to use work smarter, not harder, right? I'm using my calculator on this. This is y1, y2. So let's graph it. So turn it on, blah, blah. And again, I can just type it in the way I see it. So I'm going to do 1/3 times 1/2 times x times 2x minus 1 times 5x plus 3. Right, and that's, I put that on for y1, and for y2 I'm going to put 210. If you remember what I mentioned last time, like if I know the graph, right? The graph's going to look something to this effect. But 210's way up here. I get 210. So you got to fix the window. Right, make sure the y max is like maybe 250 or 300, and the y min could be, I mean, it could be anything. You can make it, I'll make it 0, but right, you gotta make sure your y goes all the way up to C210. So let me fix my window because it doesn't go high enough right now. I'm only going, my y max only goes to 10. I need to go to 210, so make 250, so you can kind of see it better. So you see how it's way up there now, and there's my graph, and there's 210. Now I'm going to try to find that intersection. So I'm going to put second calculator intersection. And just get a little close to it. By the way, here's a little trick I haven't taught you. If you press up, it switches to other graph. So it's like, oh, it's a 210 graph. It's a lot easier to move. So just get a little close to it. Hit enter a couple of times. And then you get intersection 5. All that work, and x equals 5. And actually the question is what's the dimension? So it would be 5. 5 times 2 minus 1, so it's 9. And then 5, 25 plus 3 is 28. So those are the dimensions. So anyway, that's the lesson.